So, hello everyone. I hope you can hear me all right. Fine? Okay, awesome. Because our head of audio, my boss, is currently not here, so he's responsible for that actually. But yeah, hi and welcome. I need my view. So, yes. So welcome to my talk about GitOps and Terraform, match made in cloud heaven. Just a heads up, this meeting is recorded, as already mentioned. So if you ask questions, you're on the recording. Yeah. So today I will show you some tools and practices on how you can leverage GitOps in your Terraform workflow. So questions just at the end. Yeah. So first, something about me. I'm Alex. I joined Runtastic in March 2020. Yeah, I'm an infrastructure engineer, which means I'm responsible for keeping up the infrastructure of our apps and our internal IT and everything else. Yeah, and I'm passionate about automation and cloud computing. And so this talk kind of shows you what I'm passionate about, actually. Yeah, and in my free time, I also love to run, hike, or game. Yeah, also with the company, we have our nice runs, our nice lunch runs. Yeah. Also, we keep our infrastructure up to date and running by leveraging Terraform and Ansible, or also still Chef. But yeah, more on that later. So just a short overview of today's agenda. I have 3 tools to show you. First is the Flux Terraform Controller, Atlantis, and the Terraform Cloud. So yeah. But first off, let's get started with some basics. So I guess most of you are aware what infrastructure as code is. But yeah, Terraform. So what is Terraform? Who has used Terraform? Hands up. Okay, so quite a lot. Nice. Yeah, so Terraform is open source. It's multi-cloud or also on-premise. So you can also use it for your local infrastructure like we do. There are lots of providers for Microsoft, Azure, AWS, and all the other cloud providers. So also just tools that you use, cloud tools, local tools. Yeah. It has also reusable modules. So if you write a big Terraform plan, you put it in a module, you can just reuse it, just fill out some variables, and you're good. It's stateful. So when you apply something, the state is stored in a state file. So if something changes, yeah, you will get to see it. Yeah. And also, the last point, I added that because something happened like 2 hours ago. Our whole production went down, actually. Yeah, and colleagues had to drive to the data center because we could not access anything anymore. Yeah, and that kind of happened because we made manual changes and Terraform then changed it. Yeah, and then it was broken. So yeah, really use infrastructure as code and don't do manual changes then. Best to have read-only even in the tools and only change stuff with Terraform or other infrastructure as code tools. Yeah, so much for that. What are other tools? I already talked about Ansible, which we also use for setting up like the software on Linux servers and the configurations and so on. Chef, we actually use that until we maybe replace it with Ansible. Let's see how that goes. There's also Puppet or AWS CloudFormation, which is the native tool used there for on AWS, or Azure Resource Manager, or in short, ARM templates. Or I think the new thing is Bicep, which is like the new language as far as I know. Yeah. Next slide. So why GitOps for Terraform? So first off, you don't need a local environment anymore. So you don't need to set up all of the secrets that you need for accessing AWS or Azure or your local infrastructure. You can just start. It enables then, because of this, better collaboration between dev and ops, so developers and operations, because the developers, they don't need the secrets, they don't need to set up everything manually, they just see the Terraform code, hopefully they know how to write the Terraform code, then they push it, make up a pull request, and then depending on the tool, you review and you deploy it. And of course, it leverages automated deployments, so depending on the tool of your choice then, you can just enable automatic deployment, so automatic applies. So if you push something, the plan is successful, it gets applied without you needing to do anything else. And because it's then documented in Git and also in pull requests, depending on the tool, you have auditing and you have a documentation and you have approvals even if you have a pull request. Yeah, and some tools also support drift detection. So then you see, okay, I created this VM. It was called Alex. Now it's called Alex2. Why did that happen? Yeah. And you maybe even set up automatic remediation so it gets changed back. So no one can change anything. Yeah, so that's some basics. Let's go into the Flux GitOps Terraform provider. Also sometimes called just controller, sorry. Also sometimes called TF controller. At least the repository is called like this. Yes. So some basics. It runs on Kubernetes with Flux. So Flux is like also a GitOps tool, same developers. And yeah, it runs on that. And it leverages, of course, then a lot of Kubernetes resources. So you can use secrets, store the credentials for the cloud providers. And it also stores the state file, for example, in secrets and the plan output. So it leverages all of the Kubernetes resources. Yeah, and it can automatically apply Terraform plans. So depending on how you configure it, you just need to change code, push it to a branch, make a pull request. As soon as you merge, it gets applied. We will see that later in action. Yeah, it has built-in drift detection. So it also detects if something changed. And it's really easy to deploy with Helm. So in the documentation, they provide you with a guide on how you can deploy it also with Flux, which makes sense, of course. Yeah, and there's also a CLI tool called TFCTL. With that, you can just get all of your Terraform repositories or plans and also see the state, the current state of if it's applied, if it's planning. Yeah, and if you read that, it may sound kind of similar to Crossplane, where we actually had a meet in March, I think, if I'm not mistaken. Yeah, and it kind of is, but instead of like leveraging extra resources, so you like write YAML code in Crossplane. In this case, you just use your existing Terraform code and push it. So it's, yeah, similar approach, but different outcome. Yeah. This is how the looks like. So this is just a tfctl get command. Let me just show you some stuff here. So this is basically just a Kubernetes namespace where it's deployed. Here you can see the name that is configured, if it's ready. And in this case, you see there's no drift. So everything is as it should be. And there's also no plan pending. So if you need an approval to apply the resources, then it would show true. You can also show what the plan is. I think it's tfctl show plan and then the resource. And then it's if you want to apply it, it gives you a message. Use apply something, commit it, and then it gets applied. So you need an extra commit to apply it if you set up manual approvals. Yes. So then some more information about it. It's developed by Weaveworks, which are also the creators of Flux, as mentioned. Weaveworks is actually the company that first coined the term GitOps. So they were the ones who came up with the name for that, to have the state stored in Git. Yeah, it's still actually pretty early in development. And actually, until like a few hours ago, I also had a separate point here that there are some bugs, but I was just using it wrong. So read the documentation. Yeah, it was because I tried to deploy something on a storage account, and it also was had a PNG. But if you add a Git repository with Flux, there are certain exclusions per default, and those image files, JPEGs, PNGs, and lots of other exclusions are, of course, then not included, and I thought it was a bug. But if you have any issue, you can just join their Slack, and I think I got a response in like 5 minutes. So yeah, which already helped, which is really nice. So they are really active right now. Yeah, There are also a lot of upcoming features because, as I said, it's still pretty early in development. So right now, there's no like pull request flow. So you kind of need to build it yourself, or you need to use TFCTL. Yeah, so that is coming. Also, the Terraform version is fixed right now. So I think it's 1.3 something, which of course is like a little outdated, but that will change also. And cloud cost estimation. So you will see how much the VM will cost you. Yeah, exactly. The file extension node is also on the bottom. So if you face that, it's in the repo. I will share later. And now let's try something that will hopefully not fail and do a demo. So yes, I'm still connected, so that's good. So I'm good. It's a MacBook. I have a lot of gestures. So yeah. So here you can see my terminal actually. So here you can see tfctl get, the command. And this basically shows you, I mean, it's like sadly a little bit cramped because of this approval. But here you can see the TF controller AWS. The state is unknown actually, and the plan is generated. So it says set this to approve this plan. So until this happens, nothing will change. So until then, it will just stay at this state. For the other two, automatic, I set up the automatic applies. So that means as soon as I push something, until the next time it pulls the Git repo, it's applied instantly. So that actually happens really fast. Yeah. So just to show you this, then let's go over back to the Chrome. So yes. So is it big enough? Can you kind of read it? Okay. So this is actually the Flux infra repository. So this thing is responsible for deploying Flux and the TF controller in a Kubernetes environment. In my case, it's just like a single node K3s, which is enough for the things I'm doing. Yeah. So what you can see here, in there, I have a TF controller app, and this deploys some Kubernetes resources. So the important part is you need the repositories. So we just make it even bigger. Yeah. So this is, for example, the repository, and this is the section that also includes PNGs, if you're wondering. So don't ignore. So just include everything. Screw it. Yeah. The other resources, of course, like namespace, all the others, the custom resources are here. So this is actually these are the TF controller resources. So they are custom resource. So if we look at the AWS thing, you can see it goes to infra, contrib, flux, and it's still alpha, so it's really early. Yeah, but here you can see the configuration. So kind is Terraform. Then you can see the name, the namespace where it's deployed to, how often it gets pulled. So in this case, just 1 minute. And in this case, it's approved plan auto. So as soon as I change something in the branch, which is configured in the repository, then it gets applied instantly. In this case, because I have multiple folders, multiple Terraform plans in my TF AWS repository, I had to configure this path because the others are for the other tools. Yeah, and there you could also do a force unlock if something gets locked or some log did not get deleted, a Terraform lock, which prevents others from changing stuff. Store human readable plan is also useful because otherwise you won't be able to properly read the Terraform plan, which is not optimal. Refresh before apply was actually the thing that was suggested to me by the developer. So I can use the PNGs, which did not work. Yeah, and you can also see I get the secrets for accessing the cloud account from a Kubernetes secret that is called AWS credentials. So in this credential, you can find the access key and the secret key. Yes, so that is actually this part. And now we see the repository, what is actually happening. So here you can see the folders. And in this case, the TF controller is the one we want. So you can just see a regular Terraform plan. It's really pretty simple. In the main TF, you see it's the AWS provider in this case. You have the variables that get filled then with the access key, and there they are used. Yeah, and what does it deploy actually? It deploys a bucket, it configures a website configuration, yeah, the regular stuff I would say, and then I deploy some resources. And here you can see my workaround for deploying the PNG. I just use base64 as the content, which worked, but it's of course not as nice to change stuff in there. Yeah, so that is done. If I or you go to bucket.imroot.at, you can see this. This is actually what was deployed by the Flux Terraform controller, and the QR code just links back to the repository where the configurations are. Yeah, and I think I have a pull request open on my GitHub, which is TF controller add error HTML. So if I go right now to the bucket and enter error.html, I'm sharing soon. So you will see this because it's not here. So if I'm going back here, I can just merge it. I mean, we can also view the change, which is just the error HTML. So now, moment of truth, if everything works. So confirm merge. So that's done. And in about, I would say, 1 to 2 minutes, it should actually get deployed. So we should actually see the error HTML then, because it does it automatically. Because there's no approval set for that. We saw the auto apply. Yeah. So I can now switch back actually to the terminal. And if I just did the tfctl get, and then you can see here a plan. Oh no, actually it's at no drift. This is the first one, is the one that takes a while. So usually you're not even noticing it, because if it's auto apply, at some point it will just deploy it and it will say no drift. I mean, you can of course see the commit ID to find out more about that. So yeah, right now it's reconciliation in progress. So let's see if it detects any changes. Initializing Terraform planning. So now we can see it's doing something. It should then switch over to applying already, actually, soon. Applying, yeah. So now it's applying already, which should not take applied successfully. So a demo that works. And if I again switch over, tada, the error page is here and deployed. Yes. Thank you. So then let's switch back. So this was the demo of Flux. You see, I'm also still playing around with it. I said it's still a pretty new tool. I'm also still figuring it out. So we also don't use it right now at Runtastic. So we're just like evaluating. But it's really a nice tool. So, and now let's see the next tool, which is Atlantis, which we found. Yeah, and this is actually already used in our infrastructure. So we mainly use it just so we have the pull request, we let some other colleagues watch it, and then we apply the changes there. And we also use it for cross-team collaboration. So like, let's say an architect wants to deploy something in the cloud. He knows how to write the Terraform code, or he gets help from us. He commits it. We can also make changes, but he can also plan it himself then via Atlantis in the pull request. Yeah. Let's see it here. So Atlantis, there have a lot of ways of deploying it actually. The easiest thing is to just spawn it up with Docker or let it run on KDS, or just use the old way, just install it on a server. Yeah, it integrates into most version control systems. So Bitbucket, GitHub, GitLab, easy to set up there. Yeah, and it provides an easy to understand pull request flow. So usually it works like this. Someone changes code in a new branch. He opens a pull request. And the pull request triggers Atlantis. So Atlantis then checks out the Git repo, makes a Terraform plan, and puts the output into the pull request. And you can then configure what it will require in the Atlantis YAML, for example. You also configure there which plans, for example, which folders in a repository you want to plan actually, and with which Terraform version, because it supports that, you can choose. Yeah, and then if, for example, an approval of a pull request is done, is marked as approved, then either the one who created it or somebody else can just comment Atlantis apply, and then the Terraform plan gets applied. It's easy as that. And let's take a look at how this looks actually. So in GitHub, this is how it looks like. The output is collapsed here because otherwise you would anyways not be able to read it, but it would show what will be changed. And it also tells you on the bottom, use apply or use plan again to replan, or also use Atlantis unlock to delete the lock, because a plan is always locked by one pull request. Yeah. As said, for us, it's really stable and it's already used in our production environment. Yeah, and especially compared to TF Controller, it's pretty mature project. Yeah. It works a little bit different than Terraform Controller, so you miss some of the features of Terraform Controller also. So for example, the drift detection is missing. There are no automatic applies, but it has the Terraform version selection. So that we need that for sure, but because we have a lot of old Terraform plans, so like 0.11 and so on, but we're working on it. So yeah. So short demo of that. So I have another page that has a 404 in this case. So yeah, nothing is here. So it says here TF Atlantis bucket. Yeah, because it's actually not deployed yet. So if we go over to GitHub, you see there's still a pull request open. And it actually failed the first time because I had an error in there. Yeah, it will also tell you what the error is, so you can fix it. And I configured it in a way that if a push happens, it automatically plans again. And here, then it worked. So here we can see the output. It would create a bucket that is called like this, and also add content. So here it tells me how do I apply it. So in this case, just go ahead, go down here, and comment. And if Atlantis runs, it should make an eye here. Yeah. So it's just to show you Atlantis has seen it and it will do something now. And it's also integrated here in GitHub, so you can see that the apply is running, and now everything is passed. So you can see it was applied successfully here. Yeah, and if I go back to this page, and if I refresh, yes, it was deployed. So now it was deployed by Atlantis. Yeah, so I just have Atlantis running on a VM, which is pretty simple to do so. And also a nice feature of Atlantis is if you're here and you click on the details, it actually then shows you what Terraform is doing. So if there are some other errors, you can just go directly here, and you can also follow the progress directly here. So if a plan takes really long, you can just watch it from here which is nice. Yeah, so much for Atlantis. It's actually a pretty simple tool. So, and next up, Terraform Cloud. It's actually the tool from the creators of Terraform, the company HashiCorp. Also the HashiCorp logo that you can see on the screen right here. So yeah, Terraform Cloud. There's also Terraform Enterprise variant. It's provided by HashiCorp, as said, and it's the main benefit of it is you don't need anything to start. So you only need an account with HashiCorp. You connect it to some repository, ideally running publicly, and then you can connect it. And the default is also it has cloud agents, which is like the Atlantis thing that applies the whole thing. Yeah, so that's also included in that. There's also an on-premise version if you want to run it locally in your data center, but that is only available in the enterprise version. Yeah, and they also have an automatic apply features, drift detection, which is sadly also a premium feature, and lots of other features. So it's really pretty nice tool to have. Yeah, then let's see how this looks like. So here you can see Terraform Cloud. This is just the interface. You can see some details here, which like what is the repository name, the Terraform version that is used. Yeah. So, and you can also see I triggered a run by the UI, and it was applied, and it applied 3 resources. So you can see the small green thing here today. Here. Yeah. So more on that. It's just a great place to try out actually Terraform with GitOps because it's free, and as I said, it's easy to start. And it has lots of features also that are nice. And of course, it gets updated and updated. And it always supports the latest Terraform version, of course. Yeah, and you have support by HashiCorp. So if you pay for it, you get support. Otherwise, you get community support. It has integrated Sentinel policy support. So if you can configure Sentinel policies, I think you can actually also do this with Atlantis. And it can even be used in combination with Atlantis. So you can, for example, connect Atlantis to Terraform Cloud. Same actually goes for the Terraform controller by Flux. It's still a work in progress, but they are planning so you can store the state of your plan, for example, in Terraform Cloud instead of on your local Kubernetes. And it's free for the first 500 resources. So for smaller things, it's nice. Then it gets a little expensive depending on how many resources you have. So try to cut down on the resources. It's then 10 cents per resource and per month. Yeah. And last demo for today. So this will be a quick one. So here you can see the interface. So I can go back. So this is just the overview. And here you can see all of my projects and workspaces and their status. So it's in this case, it's cost estimated. The others are applied or planned and finished. Yeah. So let's go into this plan. And we, of course, again, have a page that is not working. In this case, Terraform Cloud. So, and here you can see the plan output actually. Terraform Cloud also supports this cost estimation. So it should actually show you how much this would cost. In this case, it's just a storage account. So it does not show any cost output actually. If you deploy maybe a VM, it maybe show, depending on the size of the VM, how much it would cost. In this case, no. So here you can see the resources, what type of resources when it was created. This is just the state right now. And here you can see the plan. So you can see apply is pending. The plan is finished. So if you go here, you have a nice visual representation of the thing with some details. You can also download the raw log, or you could also configure it so it shows the default Terraform output and not this fancier UI. Yeah, here you can see the cost estimation. So it anyway says could not be estimated. Not sure how the support there is actually. Yeah, apply is pending. So this is what would be created, of course, another bucket. So I can confirm and apply here. yes, run confirmed, and then you can see applies queued on their cloud agents, applies running. It's actually pretty fast, even in the free version. So yeah, let's see if everything gets deployed. And the good thing about this is also you can really easily share plans with colleagues. So you can set up teams, you can set up who has permissions on what, who can do what. Yeah, so it's pretty nice. Yeah, so as you see, the apply is finished successfully. And if we go back, deployed by Terraform Cloud. So again, it works pretty nicely. Yeah, so last demo. And now, what are some other tools? So you can just use, for example, GitHub Actions to set up a workflow, a GitOps workflow for Terraform, which is also easy, free until you use the 3,000 free minutes on GitHub, depending on the plan. And it basically just works. You write a GitHub action, and then you just say it, okay, spawn up this container, use these commands, check out the code, plan it, post the output. Yeah, just some manual efforts, but I'm sure there are already some templates. Same thing goes for GitLab, pretty much the same. And of course, as mentioned earlier, Crossplane, not Terraform, but just different tool, different approach on how to tackle this. There's also still other tools like Spacelift, for example. They're also, I think, a pretty new tool. And if I'm not mistaken, they even bought the word Atlantis on Google. So as soon as you search Atlantis Terraform, they will get mentioned at the top and say, hey, you're trying to switch from Atlantis, use this tool. And it supports more than Terraform. Even it also supports Ansible and other things. So have not tried it out, planning on trying it out. Yeah, and the last tool, AWX, or some people may know it as the Ansible Tower or Ansible Controller. It's the open source variant of that, actually. And that can be used for Ansible. So if you have Ansible codes, we also use that, actually, to set up our infrastructure. We even configure it in a way to deploy resources from AWX with Terraform, and then let Ansible run and deploy stuff on our VMs. So it's kind of a combination that we use here. Yeah, so those are the tools. In summary, GitOps increases collaboration between colleagues, between teams. There are various tools for different use cases. So just shown you a few. You get better visibility of the actual state of your infrastructure. And you also make sure that the infrastructure stays the same. If you apply policies, permissions, you get automated rollouts. So for example, with the TF controller, just push to the branch and it gets rolled out, as you've seen. And of course, auditing documentation, which is nice, and policies and approvals, already mentioned that. Yeah, and actually that sums the presentation up. Yeah, and I guess we still have time for some questions. So, any questions so far?
I have a questions about the permission system. Like you typed some command into the comments of GitHub. Is it like it's just everybody who has access to the comments can run this command, or how is this working?
Yeah, so the way that works is you set this up, actually. So in best case, you have approvals of pull requests, which are maintainers of the repository, hopefully. And then you also set up Atlantis, so only those people can approve, or only it can be approved if someone of them gives an approval. I think there are more granular permissions to be set. Yeah, but usually it works like this. So if someone would create a pull request, they will not be able to apply it. They could maybe plan it, but not apply it. Yeah.
Okay, thank you.
Hi, Alex. Nice to see you
Hi,
again.
Gerhard.
And see the evolution of the infrastructure. But I have a question. Is this Flux workflow intended to used more on the infrastructure side, or you intend to use this also for the application deployments?
That's a good question. Actually, we're really not so far yet to make sure of that, but I think we were like seeing it more of a replacement of our Atlantis stack, so more deploying the infrastructure. Yeah.
Okay.
But let's see, maybe we will advance this to also include applications and more.
Okay, nice to hear. One interesting tool I missed at the end of the thing is if you also have in focus application deployment is Argo CD.
Yeah, there's also Argo CD. That's true. Yeah, I kind of left that out actually. But yeah, that would of course also be an option for sure.
Thank you.
Thank you.
How do you initially deploy Flux and the
Yeah,
cluster
that's
itself? The question always comes up. Right?
Yeah, that question always comes up. So in this case, I even have it in the repository. So there's a Terraform plan that you need to execute locally on your machine, and then you're good to go. So it's like this initial setup needs to be done. Maybe there are other ways. If so, please enlighten me. But yeah, as said, it's included. I will anyway share QR codes later that link to the repositories. And there is just a Terraform plan that sets up a VM, installs Flux, installs all of the dependencies, and then you're good to go, actually. Yeah.
Thank you.
I have one. Where do you store the TF state files?
Yeah, sure. So the TF state file in Terraform Cloud, it just gets deployed, stored in Terraform Cloud, so you don't need to do anything, actually. It kind of works automatically. For Atlantis, I stored it on a storage account, so like an S3 or Azure storage account. And for the Flux Terraform controller, it's stored in a secret, as said. Yeah, so in a Kubernetes secret. But you can also configure that to be stored somewhere else, wherever you want it. Yeah.
Awesome. Have you ever deleted it?
So far, because I tried out some stuff, I deleted a few of the containers, like for redeploying purposes, so you can see. And I deleted the first buckets that I also used to store the Atlantis state. So yeah, it happens, but hopefully not in production.
Asking because I did it. So.
Okay, yeah. Make sure to have backups, also always a good thing.
Awesome. Yep. Thank you very much. Yep.
Yeah, awesome. Thank you for your attention. Here are some links to the repositories, so those two, but the slides will anyways be shared later. And if you have any more questions, yeah, feel free to approach me afterwards. Yeah.
Cool.
Thanks.
Awesome.